I'm Anil Kumar sharing with you 4 difficult questions on sequences. I'd like you to pause the video, copy these questions, try them out, and then look into my suggestions. Now, these questions are from previous test papers, and most of the time it is very difficult to solve these questions if you haven't tried similar ones earlier, right? That's very clear. Question number 1A is, describe the sequence 3, 3, 4, 8, 10, 30, 33. Determine next 4 terms. Perfect. 2A. Describe the sequence 2, 11, 54, 271, 1354, 6771, 33854, and so on. Determine the next 3 terms. Now question number 3 is, write the next 3 terms of the sequence 1, minus 2, minus 2, 4, minus 8, minus 32, 256. Part B is, write a recursive formula for the sequence, right? Question number 4. Find the general term of the sequence 2, 10, 30, 68, 130, 222, 350, 520. So that's the question for you. It'll give you good practice on sequences to begin with. It's a variety of questions. You have to write next terms. You have to write recursive formula. Now when I say recursive formula, that means you have to write Tn in terms of Tn minus 1, maybe in terms of Tn minus 2. Perfect. So that becomes a recursive formula. And general term is like an explicit formula. Is it okay? So you have to write explicit formula in this particular case. So that's the question for you. Now let's try to solve them one by one. We'll look into these sequences and understand the concept. Question number 1A. Describe the sequence 3, 3, 4, 8, 10, 30, 33. So let's write down these numbers. We have 3, 3, 4, 8, 10, 30, 33, and so on. So how does this sequence go? We know this is our term number 1, this is term number 2, 3, 4, 5, 6, 7, and so on. Okay. So how do you think it is moving? Do you see some kind of pattern? Okay, you will observe from here that as far as these numbers are concerned, sometimes you see a jump, right? With a huge jump, sometimes just a small change. So let us say the small change is because of adding something. So I can say from here to here, it is like plus 3, right? Okay, so if this is plus 3 kind of thing. And here to here, we observe that's like plus 2. And from here to here, it is like plus 1. Okay, so that is alternately some sequence we could figure out. And what else? What else? Okay, what else? We see that 4 times 2 is 8, right? Times 2. And here we see that is times 3. And if I go 1 here, it is times 1. Makes sense, right? So that makes sense. So what we see here is alternately we are multiplying by increasing number, and alternately we are adding by increasing number. Does it make sense to you, right? So to begin with 33, now it is the term to multiply, right? So we have to multiply by 4 to get the next number, right? So from 33, we should do times 4. And once we have done times 4, then we should add 4. Perfect. That is how our sequence is moving. And then what should we do? We should do times 5. And then we should add 5. Perfect. That makes sense, right? So that is a pattern here. So we'll do 33 times 4, which is equal to 132. So we get 132 here, and we'll add 4 to this. So we get 136. We'll multiply that by 5 times 5. We get 680. Okay, so we get 680. And then we'll add 5. So we get 685. Do you see that? So we did get a pattern which helped us to figure it out. But it is not an easy pattern, as you can see. Right? But once you have done a pattern like this, it should not be difficult. Question number 2a. Describe the sequence 2, 11, 54, 271, 1354, 6771, 33854. Now the numbers rapidly increase, right? So let me rewrite this. It is like 2, 11, 54. So there is a lot of trial and error required in solving such questions. Trial and error probably is the best method. So 33854. Okay. Since they are going up very high, we should check whether they are in geometric sequence or not. Okay. So let me do 11 divided by 2. What do I get? So 11 divided by 2 is in decimals 5.5. Okay. So let's do some other number. Let's say, let's do 6771 divided by, so we'll try this out. What is 6771 divided by 1354? Let's try this. 6771 divided by 1354 is in decimals 5, even 5. So this is 5. Okay, very good. Now let's try this number. So it is 33854 divided by 6771 equals to 4.99. So when I 3854 by 6771, I get 4.99, which is closer but not 5. Okay. Let me try this one. That is dividing 1354 by 271. What do I get? 1354 divided by 271. I get 4.99. Again 4.99. Okay. So let me try 271 divided by 54. Okay. 271 divided by 54 gives me 5.01. So what I see here is that that it is close to 5, right? So the ratio, so what I notice here is that ratio is close to 5. Ratio is close to 5. Okay. So we got some idea. Ratio is close to 5. That means times 5 can work, right? So now let's redo the work. So if I do 2 times 5, so if I multiply this by 5, I get 10. And to get 11, I have to add 1, right? So that gives me a pattern here. So I can reach from here to there by times 5 plus 1. Now, how do I get to this? Well, this time, if I do times 5, I get 55. To get 54, I have to do minus 1. Okay, let's try the next one. But still, they are kind of related, right? So now let us do 54 times 5. We get what? We get 270. So this time times 5 plus 1 is 271. Then let us check if times 5 minus 1 works or not, right? So we have 271 times 5 equals to minus 1 equals to 1354. It works. Perfect. So now we got a pattern. Do you see that? So 1354, it works. So the pattern here is kind of, we are multiplying by 5 and then alternately we are adding and subtracting 1, right? So that is the pattern. Do you see that? So we can apply this pattern and get to the next term. Correct? So we have to get three terms. So it should be 33854. So now, to get to, this is term number, let me write down term numbers. It becomes easier actually, right? So this is like 1, 2, 3, 4, 5, 6, 7. So what we notice here is to get to even numbers, we have to add, right? So now we are getting to, this is term number 7, right? This is term number 7. We want 8th number. So in this case, we have to add 1. So what are we going to do now? We are going to times 5 plus 1, correct? Get a number. And then from there, we will do times 5 minus 1. And then from there, we will do times 5 plus 1. So we'll follow this pattern. Let's do it. So we have 33854 times 5, and we are going to add 1 to this to get our number, which is 169271. So we get 169271. To get the next number, we'll do times 5, take away 1, So which is 846, okay? 846, 350. And now we'll do times 5 and plus 1. And that gives us huge 6231751. But anyway, we figured out the technique, right? So alternately, you are adding and subtracting 1 to get to even number of term numbers you're adding. Okay, so you have a clue now how to write. So as a question, what you should do is you should write an recursive formula for this particular case. Okay, so I hope that helps. So let's move on and take up the solution for question 3. Here is question number 3, and I hope you are enjoying this journey of learning how to form the sequences, and now we will see how to write formulas for them. Question number 3 here is, write the next 3 terms of the sequence 1, minus 2, 4, minus 8, minus 32, 256, and so on. And part B is, write a recursive formula for the sequence, right? So the terms given to us are 1, minus 2, 4, minus 8, minus 32, 256. So it's a good practice to write the term numbers. So let's write term numbers first, right? So 1, 2, 3, 4, 5, 6, 7, and so on. As you can see, they are all powers of 2, and what you see is sign is changing. But what you also notice is that the sign changes like 1, 2 negatives, 1 positive, 2 negatives, 1 positive. That is the pattern. Recognize the pattern. This is very important. Okay. All are multiples of 2s, so they are kind of related with 2 to the power of n. Okay. How do we get the next 3 terms, and how do we write recursive formula? That is the question. Now when you analyze it further, you will notice that how do I get minus 2 from these 2 terms? So if I multiply these 2, I get minus 2. So the pattern seems to be product of previous 2 terms is equal to next term. Correct? If I do 4 times 8, I get 32 with a negative sign since it is minus 8. When I multiply these 2, I get a positive sign. 8 times 2, 16, and 8 times 3 is 24 plus 1, 256. It makes sense. So we get our formula also. Using the formula, we can always write the next terms, right? So what we see here is that the formula. So I'm writing the recursive formula first. That is, our first term should be 1, and then our second term should be minus 2, and then nth term is tn minus 1 times tn minus 2. So that becomes the recursive formula for us. So I took the liberty of writing the recursive formula first, which is 3b. And now we'll actually use the calculator, multiply the previous two terms, and write down the next term. So the next term should be negative when I multiply these two terms, negative and negative what? 32 times 256. 256 equals to 8192. And the next term should be again negative. Since 8192 is negative, so we get negative 8192 times 256, and that is, oh my god, so it is 2097152. Is it okay? So I squeezed it in. So that is how we get this number. Okay, so I hope you can see it. So those are the two next terms, right? So we get here minus 8192, and the other term is 209 7152, 7152, and that's the pattern. Perfect. So that is how you can get it. Now let's move on to the last question on sequences. Here is question number 4, which is also the last question of our challenge round on sequences. The question is, write the general term of the sequence 2, 10, 30, 68, 130, 222, 350, 520, and so on. You can always pause the video, try it out, and then look into my suggestion. Now, to find a general sequence, what we can do is we can find difference of each term. So what is the difference between these two, those two, and then likewise? We need to get a formula, right? That's kind of very important. There is a pattern which we could see, but to get a formula, we'll follow this particular method. So we call this as first difference. So first difference is 10 minus 2, which is 8, 30 minus 10, which is 20, 68 minus 30, which is 38, right? So I should have written them further away. Anyway, so now let's use calculator. 130 minus 68 equals to 62. So I'll write here 62. Then 222 take away 130. 130 is 92. This is 92. And then 350 take away 222 is 128. So I'm writing here 128. And then we have 520 take away 350. 350 is 170, right? It's 170. So likewise, the sequence goes on. Now we will do the second difference. Okay, so now we'll do second difference, that is difference of these two, difference of those two, then these two. Is it okay? And these two, and so on. Correct? So what we get here is 20 take away 8 is 12, 38 take away 20 is 18, and then we'll do 62 take away 38 is 24, 92 take away, this is 30, okay, so 128 take away 92 is 36, so they are going up by 6, right? So you see a pattern now, correct? 170 take away 128 is 42. Yes, they are going up by 6, and as expected, if I do the difference now, which is the third difference, so this one will be third difference for us, correct? Earlier one was second difference. Let me write down. So the third difference for us is 6, which is constant. So third difference is constant, equals to 6. That means we have a relation which is cubic in nature. So cubic polynomial relates each term. So for normally for most of the sequences, what we can do is we can always find finite differences, and whenever we come across a constant finite difference, we know that degree of polynomial could represent those terms. Perfect. So that's a very standard method of doing, and it is a foolproof method. So we know it's cubic equation. Now we could solve a cubic equation and do it, but since we know, we'll apply a shortcut method. So we have our terms, which are, I'm rewriting now, 2, 10, 30, 68, 130, 222, 350, and 520. Now we know it is cubic, correct? So what we can do is we can try, this term number is 1. Let me write down the term numbers on top of them. 1, 2, 3, 4, 5, 6, 7, 8, and so on. So how is it related with 1 cube? So if I do 1 cube to get 2, I have to add 1. For 10, 2 cube is 8, 8 plus 2 is 10, and 30, 3 cube is 27, plus 3 is 30. 4 cube is 64, plus 4 gives you the thing, right? Let me check this now. So what I'm trying to check here is, what is 7 cube plus 7? This is what I'm going to check, right? So we are doing 7 cube, and we'll add 7 to this and get what? 350, right? So it is 350. So it works. Do you see that? So we have a formula, which is the general term. So we can say general term Tn is equal to n cube plus n. Perfect. That is how you can easily get solution of this particular type of question. So I hope this series is very useful. It's a startup for sequences in series. 7.3 is the unit chapter number, right? So I hope that gives you fairly good amount of practice of how to find sequences, their recursive formulas, and general formulas. Feel free to share your comments and your previous test papers so that we can come across with some good questions for other students. Thanks for watching, and if you share my videos with your friends, and if you like them, that'd be even better for me. Thank you, and all the best.